Turbo-Hydramatic or Turbo-Hydramatic is the registered trade name for a family of automatic transmissions developed and produced by General Motors. These transmissions mate a three-element turbine torque converter to a Simpson planetary geartrain, providing 3 forward speeds plus reverse. The Turbo-Hydramatic or Turbo-Hydramatic series was developed to replace both the original Hydramatic models and the Buick Dynaflow. In its original incarnation as the Turbo-Hydramatic 400, it was first used in the 1964 model year in Cadillacs. The Buick version, which followed shortly thereafter, was known as the Super-Turbine 400. By 1973, THM units had replaced all of GM's other automatic transmissions including Chevrolet's Powerglide, Buick's Super-Turbine 300, and Oldsmobile's Jetaway. Starting in the early 1980s, the Turbo-Hydramatic was gradually supplanted by 4-speed automatics, some of which continue to use the Hydramatic trade name. Although the Turbo-Hydramatic name alludes to the original Hydramatic developed by General Motors' Cadillac division in the late 1930s, the two transmissions were not mechanically related. Super-Turbine 400/THM 400/THM 375/3L80/3L80HD. The THM 400 can be visually identified by an oil pan number 4 shown at transmission pans. First introduced for the 1964 model year under the name Turbo-Hydramatic in Cadillacs and Super-Turbine in Buicks. The following year, application expanded to Oldsmobile and Pontiac and to some full-sized Chevrolets. Many of the Buick, Cadillac, and Oldsmobile THM 400s produced between 1964-67 were equipped with a switch pitch torque converter with a variable pitch stator, which is sought after by collectors and drag racers. These can be identified outside the vehicle by a narrow front pump spline. Externally, the switch pitch version has 2 electrical connections, where the non-switch pitch THM 400 has only one. GM used a switch pitch torque converter in the Buick twin-turbine Dynaflow transmission between 1955–1963 and the Super-Turbine 300 2-speed transmissions used by Oldsmobile Pontiac and Buick divisions between 1964–1967. This transmission is identified by the Park RMDL2L1 selector quadrant. A variant of the THM 400 known as a THM 375 is a THM 400 with a long output shaft that mates to the smaller THM 350 drive shaft yoke. It can be identified by 375 THM cast in the tail housing. Internally, the clutch packs originally had fewer friction plates. Some heavy-duty THM 350s were also designated THM 375B. Another variant is the 3L80HD, often referred to as a Turbo 475. The 3L80HD has a straight-cut planetary gear set. There is no externally visible way to determine whether the transmission contains the straight-cut planetary gear set. The THM 425 front-wheel drive transmission shares almost all its internal parts with the THM 400. Checker Motors Corporation Motor Company used the Chevrolet version of the THM 400 for its A-Series taxi and marathon models until the end of production in 1982. By 1980, the relatively heavy THM 400 was being phased out of usage in passenger cars in response to demand for improved fuel economy. The THM 400 was utilized in the C and K Series Chevrolet GMC pickups and G-Series vans until 1990 when GM switched over to the 4L80E. Today, the United States Army HMMWV is the only vehicle using the THM 400. The civilian Hummer H1 originally had the 3L80S, but the current model has had a 4L80E since the mid-1990s. Through the end of the 70s, substantially more CBOP bell housing THM 400s were produced than any other THM 400. Chevrolet bell housing THM 400s, while not rare, can be hard to find and are, as a result, usually more expensive to buy. The THM 400 was never produced with a multi-case bell housing. Other auto manufacturers have used the THM 400 and its 4L80E successor, including Ferrari, Jaguar, Daimler and their Daimler stablemates, Rolls-Royce, the Nissan Prince Royal, AM General, and Jeep. Early Jeep THM 400s used an adapter between the engine and transmission bell housing, while later models had an AMC-specific housing. Though identical except for the bell housing pattern used through the 60s and ending in 1979, the THM 400 was mated to the Dana Model 1820 and was the only transmission used with the Borg-Warner 1305/1339 all-wheel drive transfer case, used only in Jeeps. It has been known to adapt a THM 400 to other engines using adapters. THM 400 transmissions are very popular in automotive competition due to their great strength. Much of this strength comes from the use of a cast-iron center support to suspend the transmission's concentric shafts that join the clutch assemblies to the gear train. The center support, which is splined to the interior of the transmission's case, also provides a robust reaction point for first gear. Since the first gear reactive force is evenly distributed around the periphery of the case, the types of mechanical failures that have plagued other competition transmissions are rare. The THM 400 was the first 3-speed, Simpson-geared automatic to use overrunning clutches for both first and second gear reaction, a feature that eliminated the need to coordinate the simultaneous release of a band and application of a clutch to make the 2 to 3 gear change. Owing to this feature, as well as the use of a large, multi-plate clutch to provide second gear reaction, the THM 400 is able to withstand very high input torque and an enormous number of shifting cycles, as would be encountered in frequent stop-and-go driving. As a result, it has met with considerable success in commercial vehicle applications. For 1987, GM changed the nomenclature of their Turbo Hydra-Matic transmissions. The THM 400 was renamed to the 3L80. The 3L80 HD was introduced in 1987 as the HD unit used in passenger trucks. In 1991, a 4-speed overdrive version, the 4L80E, replaced the THM 400 in Chevrolet GMC pickups, vans, SUVs, and commercial vehicles. The 4L80E was the first Hydra-Matic to incorporate electronic controls. Almost all of the THM 4000 3L80 HD's components are interchangeable. Transmission fluid cooler line connections are found on the right-hand side of the THM 400. The lower connection is the cooler feed, and the upper connection is the return. The case is tapped for either self-sealing 1/4 NPT fittings, or 1/2 UNF fittings with a washer seal. 5/16, or 3/8 rigid coolant lines are generally connected via appropriate double-flared adapters. Four-wheel drive truck applications used a shorter output shaft that coupled with a female transfer case input shaft. Early transfer cases mated directly to the THM 400 with a cast-iron adapter, usually a vertical oval shape. Later models used a circular-style iron adapter, which is generally considered the stronger of the two. Gear ratios are, first gear, 2.481, second gear, 1.481, third gear, 1.001, reverse, 2.071. THM 350. The Turbo Hydra-Matic 350 was first used in 1969 model cars. It was developed jointly by Buick and Chevrolet to replace the 2-speed Super-Turbine 300 and aluminum case Powerglide transmissions. So, although it carries the Turbo Hydra-Matic name, the Hydra-Matic division of General Motors had little, if anything, to do with its design. The 350 and its 250, 250C, 350C and 375B derivatives have been manufactured by Buick in its Flint, Michigan, plant and by Chevrolet in Toledo and Parma, Ohio, and Windsor, Ontario. Both Chevrolet and Buick divisions produced the THM 350. The THM 350 was also regarded as a 3-speed Powerglide and during its development, was generally called this. Although it uses the same torque converter as the THM 400, it has a familial resemblance to the 1962-73 aluminum Powerglide from Chevrolet and was largely derived from the Chevrolet design. One important difference in the THM 350 compared to the THM 400 is there is no fixed center support midway through the geartrain. This important difference in layout permitted THM 350 to be adapted to the conveyor where the drive and driven ends are the same. This feature was not exploited. Air-cooled versions of the THM 350 appeared mid-1972 in Chevrolet Vega and Nova 6. One THM 350 weak point was excessive end-play between the pump and center support and resulting wobble of the direct clutch drum due to both the end-play and use of a relatively narrow bushing in the drum. This weak point can be addressed by using an extra thrust washer between the planetary gear and direct clutch to remove the end-play and using a wider aftermarket bushing in the direct clutch drum. Another weak point is the relatively thin center support and the lightweight matching splines in the case. This weakness can be addressed by using an inexpensive aftermarket case saver kit. Four-wheel drive truck applications for the THM 350 used an iron adapter that mated the THM 350 to the transfer case directly, similar to the THM 400. The THM 350 adapter was cast iron and used a sliding sleeve to couple the transmission output shaft to the transfer case input shaft with a steel coupler sleeve that was splined to accept both shafts and couple them together. An internal snap ring inside the coupler sleeve controlled the sleeve's position on the shafts, with circular seals in the adapter sealing the transmission from the transfer case. Around 1980, a lock-up torque converter was introduced. This transmission was phased out in 1984 in GM passenger cars for the 700R4. Chevrolet GMC trucks and vans used the THM 350C until 1986. The lock-up torque converter was unpopular with transmission builders. B&M Racing once marketed a conversion kit for THM 350CS during the early 1980s until the advent of high-stall lock-up torque converters when its overdrive counterpart were modified. The standard TH350 is still very popular in drag racing. THM 250 The THM 250 is a derivative of the THM 350 and was introduced in 1974 in Chevrolets as a Powerglide replacement. Internally, the THM 250 is a THM 350 without the intermediate clutch pack with a band adjuster similar to the Powerglide. It was later reintroduced in 1979 as the THM 250C in the wake of the failure-prone THM 200/200C. Gear ratios: THM 350,250,250C, first 2.52 January 2nd 1.52 January 3rd 1.001, reverse, 2.071. THM 200. Right after the 1973 OPEC oil embargo, GM developed a lighter-duty version of the THM 350 with lightened materials, primarily alloys in place of ferrous materials, the Turbo Hydra-Matic 200. The THM 200 was first used in 1976 models including GM's T-Cars and X-Cars. However, this transmission was notorious for its failure rate when used behind too large an engine. Starting with the 1979 model year, vehicles which had the THM 200/200C as standard equipment were optioned with the THM 250C, which is a THM 350 without the intermediate clutch pack along with an adjustable band similar to the Chevrolet Powerglide. Around 1979, the THM 200 received a lock-up torque converter, and some internal components were later shared with the Turbo Hydra-Matic 200-4R. THM 200/200CS were produced until 1987. The gearing for the 200C is, first, 2.741 second-1.571, third, 1.001, reverse, 2.071. THM 200-4 rankings equals, for the 1981 model year, the 200-4R was introduced. The components which were prone to failure in the THM 200 were improved, and this transmission was used with high-power applications, primarily the Buick Grand National. The 200-4R was configured with several different torque converters and gear ratios depending on the vehicle application. Unlike the 700R4, most 200-4RS have a multi-case bell housing for use with Chevrolet, Buick Pontiac, and Cadillac engines. However, 200-4RS share mounting locations with the TH400. Since the external dimensions are similar to the TH350, 200-4RS are often swapped in place of TH350s in older vehicles to provide an overdrive gear. Early models are PRN-D321 on the cluster, while later models are PRN-D-D21, with the left D identified as the overdrive gear by a square or oval ring. The THM 200-4R can be found in the following vehicles: 1981-90B bodies, 1981-84C bodies, 1984-88G bodies, 1985-90D bodies, 1981 Pontiac Firebird, 1989 Pontiac Firebird Trans Am Indy Pace Car. The THM 200-4R was phased out after 1990. Its final usage was in the GMB body vehicles. The gearing for the 200-4R is, first, 2.74054041 second 1.56756771, third, 1.001, fourth, 0.6739131, reverse, 2.071. THM 700R4/4L60/4L60E/4L65E/4L70E. The 4-speed Turbo-Hydramatic 700R4 was introduced for the 1982 model year for use in Chevrolet GMC vehicles. In 1990, the Turbo-Hydramatic 700R4 was renamed the 4L60. Under the new designation, the 4 stands for the number of forward gears, the L for longitudinal applications, and the 60 is the strength rating. 60 inches is the relative torque value. For example, 80 is stronger than 60, which is stronger than 40, etc. A 4L80E can handle more torque than a 4L60E. The E denotes electronically controlled shifting. The 4L60 however is hydraulically shifted based on governor pressure and TV cable position. 1992 was the last year of widespread usage of the 700R4. 1993 Camaro, Corvette and Typhoon were equipped with the last production 700R4. The last design change of the 700R4 was an added check ball to the valve body. In 1992 electronic controls were added, and it became the 4L60E. The 4L60E went into service in trucks, vans, and SUVs in 1993 and in all RWD passenger cars in 1994. In 2001, an updated version the 4L65E, was introduced. 5-pinion planetaries, along with a strength-improved output shaft, were improved to withstand the 300-plus lb-ft of torque of the 6.0 Vortec engine. The 4L70E transmission is the same as a 4L65E with a speed sensor located in the pump. Equals 700R4/4L60/4L65E/4L70E/technical description equals, the Turbo-Hydramatic 700R4 can be identified by an oil pan number 6 shown at General Motors transmission pans. The tail shaft housing is held onto the main case by 4 bolts, and uses a square-cut O-ring seal, and not a gasket. The typical width of this transmission where it bolts to the engine is 20 in overall. From the engine transmating surface to the crossmember mount bolt is 22.5 in, and engine trans surface to output shaft housing mating surface is 23.375 in overall, with the tail shaft housing typically measuring 7.625 in. Transmission fluid cooler lines on the 700R4. The bottom fitting on the right side of the transmission is the outline to the cooler and the top fitting is for the return line from the cooler. These fittings are .25 in pipe thread, and can include an adapter from the factory for threaded steel lines in SA size. 4L60 is manufactured after 1995 use snap-in connections instead of threaded. The original version of the transmission had a 27-spline input shaft which was a common failure point. In 1984, the 700R4 designed for use behind Chevrolet small block V8s received a 30-spline input shaft similar to those found on TH400 transmissions and which also used a different torque converter than its 2.8 V6 and 2.2 L4 engines. Between 1984 to 1987, internal components, from the ring gear to the oil pump housing, were updated, ending with the auxiliary valve body for 700s manufactured after October 1986. In 1995, the 4L60E received a PWM-controlled lockup converter. The early design's simple on or off lock-up function, while the later design can variably lock as to not feel the lock-up occur. GM added a fifth solenoid to the valve body, called the Pwm Solenoid. In 1996, GM introduced a redesigned 4L60E transmission case that incorporated a bolt-on bell housing and an 6-bolt tail housing. This two-piece case style was first seen in 1996 and up Model S10 Blazer, S10 Truck, GMC Jimmy, and GMC Sonoma with the 4.3L engine. In the large majority of 1998 and later applications of the 4L60E were two-piece cases. Both transmissions are the same internally. The non-PWM style 4L60s are not interchangeable with PWM style 4L60s. Also in 1996, GM changed the 3-2 solenoid to a different style which makes it not interchangeable with any previous models. For the model year 1996 GM trucks, there were two versions of the 4L60E transmissions. One had a bolt-on bell housing, the other did not. The bolt-on bell housings used on the 4.3L and 1996 to 2002 General I Plus versions of the small block Chevrolet used the same bell housing, while the LSX engines used a longer bell housing to accommodate a redesigned torque converter with a longer pilot nose. The gearing for the 700 is, first, 3.0591 second-1.6251, third, 1.0001, fourth, 0.6961, reverse, 2.2941. These ratios are commonly rounded off to 3.06, 1.63, 1.00, 0.70, and 2.29. Equals 700 are 4/4L60/4L60E/4L65E/4L70E applications equals 1982 to 1992 Chevrolet Blazer GMC Jimmy, 1982 to 2005 Chevrolet Corvette, 1983 to 1996 Chevrolet Impala and Caprice Police Specials equipped with 350 engines. 1983 to 1985 Oldsmobile 350 diesel-equipped models. 1983 to 2002 Chevrolet Camaro Pontiac Firebird. 1985 to 2005 Chevrolet Astro GMC Safari, 1991 to 1992 GMC Cyclone, 1991 to 1992 Oldsmobile Custom Cruiser, 1989 to 2003 Chevrolet S10/GMC S15/Sonoma, 1989 to 2005 Chevrolet S10 Blazer, 1989 to 2001 GMC S15 Jimmy. 1990 to 1996 RWD Cadillac Fleetwood Cadillac Brougham Cadillac Limo, 2002 to 2009 Chevrolet Trailblazer GMC Envoy, 1992 to 1993 GMC Typhoon, 1984 to 2010 Chevrolet Suburban, 1982 to 2012 Chevrolet Van, 1994 to 1996 Chevrolet Impala, 1994 to 1996 Buick Roadmaster, 1995 to 2010 Chevrolet CK, 1995 to 2010 Chevrolet Tahoe GMC Yukon, 1999 to 2006 Cadillac Escalade, 2002 to 2008 Chevrolet Avalanche, 2003 to 2007 Hummer H2, 2004-2007 Buick Rainier, 2004 to 2012 Chevrolet Colorado GMC Canyon, 1988 to 2006 Holden Commodore, 2004 to 2006 Pontiac GTO. References, Sessions, R. How to work with and modify the Turbo Hydra-Matic 400 transmission, ISBN 0-87938-267-8, pages 108, Chevrolet Geo Transmission Lookup Table, http www.autorepairmanuals.biz 573683372807, Transmission Application Chart, http www.idatc.com/ application_page.htm. External links, The Old Car Manual Project, Transmission Pans,